What's up, you guys? Mr. Dr. Professor Niemeyer here. We're getting into part 3 of surface area, calculating the formula. So let's take a look at our last figure here. It is a cylinder. I have here a jar of olives, because why not? Everyone loves olives. Let's go ahead, and I have this labeled as the height. This one probably makes the most sense to you guys, because it's vertical. Okay, I know that might be confusing in my other videos. I've labeled this as the height this time. We on the same page? Cool. Let's go ahead and look at this measurement. Notice I have labeled the distance from the center of the circle on top to the outside of the circle. Yes, it is indeed a circular shape on the top. It is a circle. What is that called? That's right, it's the diameter. Wrong, it's the radius. Radius. Alright, I know, a bunch of you I didn't fool. Anyways, moving on, surface area. So we have 3 different surfaces on this object. We got the top, we've got the bottom, and we got all the way around, all the outside. That's where the label would be that show those delicious olives. Okay, let's dive into the surface area. Let's figure out the surface area of the top. What is the area of that circle? How do you calculate that? That's right, it's going to be pi r squared. Remember, when they're right next to each other, it's like they're multiplying. I'm going to just keep that in there just because. Anyways, what is pi? What number do we use to kind of represent pi? 3.14, right? So I'll just put that as a reminder. Pi is 3.14, and sure, it goes on forever, but, you know, we got to stop at some point, right? Our calculator doesn't hold infinite number of digits. Okay, so we found the area of the top of the circle. Or excuse me, the top was the circle. What about the bottom? It's the exact same, right? The exact same thing. So it fits the pattern of my other 2 videos where we are going to take this area of the top and say, hey, it's the same as the one on the bottom, so we have 2 circular areas that are identical. We can just multiply that by 2. Now we get to the last one, this orange surface all the way around. That one's kind of tricky to calculate. Can you stop the video and figure out how would you find the area of all that orange all the way around? This one I think is kind of cool. So that is our last side that we are going to add in. So if you have like a jar or a can of anything in your house, whatever, if you take off the label, see, now it's olives, you will see it makes a rectangle. Huh, how many of you guys got that? If you did, very impressive. Anyways, we know how to calculate the rectangle. That's what? It's width times length. In this case, I'm using height, so that's kind of confusing. So let's just call this the height of the rectangle, right? That's this side. If I put it back on, yeah, that's the height. Okay, so the rectangle's area is going to be height times what? Or, in this case, you could think of it as width. That's right, it's going to be this length here. But what is that length? Well, if I put it back on here, you'll notice that the length goes all the way around this circle. So it's the distance around this circle. What do we call that distance? The circus, the circumference, right. So, how do you calculate the circumference? Oh no, we have to use the stuff we learned from last week? Come on, man. Okay, if you recall from last week, circumference is calculated by pi times 2, well, let's put the 2 in front. 2 times the radius, or that's also known as the diameter, times pi. 2 times the radius times pi gets us that length on the bottom of this rectangle. That gets us the circumference. Wow, that was pretty complex, but here it all is. So, now you have all of the derivations or where those formulas come from to calculate surface area. Again, watch the video I have where I use actual measurements to figure out the surface area for various everyday objects. Reach out to any of your teachers if you have any questions. Until next time, see ya.